In Reason, functions are first-class values. This means we can use them as any other values. So we can use them in data structures. We can also pass them as arguments to other functions. And we can return them by other functions. As we've already mentioned, functions are just values like any other values. This means they must have a particular type, which can be any type that is available in Reason. And types play an important role for functions, since they determine what is allowed in a function and what is not. Let's take a look. We defined the add-ins function, which expects two parameters and returns their sum. The compiler inferred that these parameters are integers, because we can add only integer types using this plus operator. Then we called our function by passing it two integers, and we got the result. However, if we pass arguments of different type, we will get an error. Let's try to pass two strings. We got a type error since our function expected integers. We cannot pass strings since we cannot add two strings using the plus operator. As you can see, the type of the function is crucial, since it determines what our function can do. As we've already mentioned, functions in Reason are first-class values. This means they can be used in the same way as any other values. So we can use functions in three major ways. The first one is that a function can be part of a data structure. So it can be part of a list, of a tuple, of a record, and so on. The second one is that we can pass a function as an argument to another function. And the third way is that we can return a function by another function as its result. We will now talk about these three usages in more detail. First, let's take a look at the function as a part of a complex data structure. Let's start with the record. First, we need to declare a record type. We created the random record type with three fields. The first one is add-ins, which is a functional type expecting two integers and returning another integer. The second one is concat_strings, which is also a function expecting two strings and returning another string. And the third one, called title, has a type of a string. As you can see, we can combine different types of values in record. Since we declared the type of our record, we can now create one. We created the with_functions record, which has a type of random record. The add-ins field is a function expecting two integers and returning their sum. The concat_strings field is also a function expecting two strings and concatenates them together. The title field contains a string. As you can see, we have a record containing two functions. Let's call them. To call records functions, we need to access them just as we access any other field of a record. That means using a dot notation. Then we pass expected arguments to both functions, strings and integers. And they were successfully called, and we got back the results. Now, let's create a list of functions. In a list, all elements must have a same type. In case of functions, this means that each function has to be of the same type. We created the operations list with two elements which are both functions, and they have the same type. They are both expecting two integers as arguments and return another integer. Let's call the first function. Since we are dealing with a list type, we can use a predefined function to access its element. Here we are using the list.hd function, which takes a list and returns its first element. In our example, we use this function to get the first function of the list, which adds two integers together. Then we immediately called it by passing two integers as arguments, and we got back the result. Let's talk about the second usage of a function as a first-class value, which is that we can pass a function as an argument to another function. Let's take a look at an example. We defined the add function, which adds 5 to the passed argument. We also defined the multiply function, which multiplies passed argument by 10. Finally, we have the compute function, which expects a function and a value as arguments. In its body, it calls the function with the passed value. As you can see, our function has a polymorphic type because nothing constrains the type of its values. Let's call the compute function. We called our function twice. First, we passed the add function and the integer as arguments. The compute function passed the integer to the add function and return the result. And secondly, we passed the multiply function and the integer. The compute function passed the integer to the multiply function and return the result. We can also pass a function as an argument to the recursive function. We defined the recursive compute rec function, which is a more complex version of our previous function. It has a new parameter called recCount, which determines how many times the passed function will be called. We called the compute rec function and passed it the add function. Then we passed the integer 4, which will be the argument to the add function. And finally, we pass the integer 2. This means that the add function will be called twice. In the function, we are pattern matching the rec count argument, and if it's not 0, we will recursively call our function. And each recursive call, the second argument will be getting bigger because of the add function. At the same time, the last argument will be getting smaller, and when it's equal to 0, we will compute and return the result. Let's talk about the third usage of a function as a first-class value, which is that we can return a function by another function as its result. A typical example of this behavior is a function composition, which is one of the typical features of functional programming. It allows us to combine two or more functions into a new function. Let's define the compose function, which will allow us to do this. We still have our add and multiply functions from the previous example. Moreover, we also defined the compose function, which expects 3 arguments, 2 functions, and a value. In its body, it passes the value to the second function, and the result of this computation is then passed to the first function, which will return the final result. For better understanding, let's call this function in 2 phases. In the first phase, we pass only 2 functional arguments. We pass add and multiply functions to the compose function. And we get back a new function expecting the last integer argument here, which is the last value parameter from the original compose function. We bind this function to the add multiply identifier. So this function is a function composition of add and multiply functions. In the second phase, we call the add multiply function. We pass an integer to the add multiply function. Since this was the last argument, the function gets evaluated. In the body of the compose function, the integer argument is passed to the multiply function first, which is the func2. We get back the result 50, which is immediately passed to the add function, which is func1, which returns the final result of our function composition, which is 55. Applying our function using this 2-phase approach makes it more versatile because we can reuse the add multiply function by passing different integers to it. As you can see, we can pass any integer to our function composition, and this function will pass this integer to multiply and add functions. This means we can reuse this function composition throughout our program. We need to always make sure that types of composed functions are compatible. In other words, we need to make sure that the result type of the first function is compatible with the parameter type of the second function in the composition, and so on. And thanks to Reason's strong type system, the compiler will let us know when we violate this rule. Our example works since we are using integer types consistently. the value that is passed to the function composition is an integer, and both functional arguments expect and return integers as well, as you can see here. But what if this wasn't the case? Let's take a look. By adding a dot to the plus operator and to the integer, we change the type of the add function, which now expects and returns a float type. When we called the compose function, we got an error, since in the composition, the multiply function takes an integer and returns another integer, which is then passed to the add function. However, this function expects a float and not an integer. As you can see, the compiler provided us with a type error and with a readable message telling us that our types are incompatible. It's telling us that the multiply function should return a float type, but in reality it returns an integer, and the integer is not compatible with the add function, which expects a float. So let's fix it. We fixed our add function, so it expects and returns an integer, and everything is working again. Maybe you were wondering, how is it possible that we first passed two functions to the compose function, bound it to an identifier, and passed the last argument later? Well, you will learn that in the following section.